Hey everybody! Today we're going to be talking about the wave nature of the electron. And to be more specific, we're going to be talking about how to calculate the wavelength, or the de Broglie wavelength, of an electron. It's called the de Broglie wavelength because this guy, Louis de Broglie, was among the first to propose that electrons behave like waves. By the way, please excuse my terrible French accent. Anywho, the wavelength of a particle traveling at a given velocity is given by the de Broglie relation, in which lambda, the wavelength, equals h over mv, where m is the mass of the particle, v is its velocity, and h is Planck's constant. So let's put this equation to work and solve a problem, shall we? This problem says to calculate the wavelength of an electron traveling at a velocity of 6.04 times 10 to the 7th meters per second. So of course we're going to use the de Broglie relation, where lambda equals h over mv. H, Planck's constant, is 6.626 times 10 to the minus 34 joules times seconds. You may want to commit that one to memory. We're going to divide that by the product of the mass and the velocity of the electron. The mass of an electron is 9.11 times 10 to the minus 31 kilograms. You could easily find that one in your chemistry textbook. And the velocity, which is given by the problem, is 6.04 times 10 to the 7 meters per second. So let's make sure our units cancel before we throw this into the calculator. In order to cancel the units correctly, we need to recognize that 1 joule is equal to 1 kilogram times square meters over square seconds. So if we replace joules with kilograms times square meters over square seconds in Planck's constant, then our units will cancel out just fine, leaving us with meters, a unit of length, which makes sense since we're calculating a wavelength. And the answer, kept to 3 sig figs, is 1.20 times 10 to the minus 11 meters. So there you go. That's how to calculate the wavelength of an electron using the de Broglie relation. I hope you found this video helpful. Thank you very much for watching, and as always, have a good one.